Welcome back to the Explainer, everyone. Today, we're diving into something absolutely crucial. We're talking about taking your data out of the fragile, fleeting world of temporary memory and locking it down into a secure, permanent vault. You can think of file processing as the ultimate lockbox system for your code. Because let's face it, when your app closes, file processing is the literal safety net that ensures all your hard work doesn't just vanish into thin air.
So here's our roadmap for today's Explainer. We'll start by moving beyond temporary memory, then map out the file processing cycle. After that, we'll decide whether to read, write, or append. We'll do a quick showdown of Python versus Java, learn how to trace the code like a pro, and finally, wrap up with how to avoid those common, absolute nightmare file errors.
All right, let's jump right into part one, beyond temporary memory, and how we actually secure that data.
Seriously, think about this for a second. What actually happens to your data when the screen goes black? If your program is just storing things like usernames, high scores, or user settings in standard variables, well, those are just living in temporary RAM. The exact second that program finishes executing or a user hits exit, poof, gone, kaput. That's a super high-stakes problem, right? If we want to save data, share it around, or keep any kind of historical record, we absolutely need a permanent solution. We've got to write it to a file.
Now, the specific type of file we're focusing on today is the sequential text file. It's exactly what it sounds like, data stored as characters in a rigid sequence. Think of it kind of like a physical printed book that we've locked inside our data vault. You can't just magically teleport to page 150. You have to read the pages in exact order, from the very beginning to the end. That sequential nature, that is exactly why file position and line order are so incredibly critical when we're writing our code.
Moving on to part two. Let's talk about the file processing cycle, or what I like to call the rules of the vault.
When you're dealing with permanent files, there's a strict, non-negotiable four-step protocol. First, you open. Second, you read or write. Third, you process the data. And fourth, you close. It is literally just like a physical bank vault. If you don't explicitly unlock it and swing that heavy door open, you're not getting inside. And, maybe even more importantly, if you forget to lock it back up by closing the file, your data might not be saved correctly, and you leave system resources completely tied up.
So the big takeaway here is this. A file stores data permanently, which means your program has to control access carefully. Permanent storage brings permanent responsibility. That's exactly why this four-step cycle isn't just a suggestion. It's a fundamental safeguard to keep your data intact.
Next up, part three. Read, write, or append. It's time to declare your intent.
When you open that vault, you've got three main modes to choose from. Read mode is safe and simple. You just take data out, and the file stays entirely unchanged. Append mode is great for adding new data right onto the very end of an existing file. But listen, you need to pay super close attention to write mode. If you open a file in write mode just to put some new data in, and that file already exists, bam! The old contents are completely overwritten and destroyed.
And here's a little insider tip for mapping out your logic. Don't just settle for thinking about what a mode does in theory. You really want to visualize the before and after states of the file. So instead of just saying, oh, append adds data, try to say, the original data remains perfectly intact and the new data drops in right at the end. You want to paint the whole picture of what's happening inside that vault.
All right, moving into part four. Python versus Java. Different dialects, but the exact same logic. Now, Python is beautiful here because it uses wonderfully concise, built-in functions. You literally just type open, read, write, and close. It's super direct. Java, on the other hand, well, it asks for a bit more setup. You've got to instantiate specific classes, things like scanner or BufferedReader, just to read, and FileWriter to write. But don't let that intimidate you. Despite Java being a bit more setup-heavy, both languages are doing the exact same thing under the hood. They open the vault, manipulate the data, and lock it back up tight.
Oh, and one quick aside about Java. It is incredibly cautious. File operations in Java almost always require exception handling, like those try-catch blocks. Why? Because Java is basically a worrier. It constantly stresses that the file might be missing from the vault, or maybe another program has it locked. It absolutely demands a backup plan before it even attempts to turn the key.
Let's keep rolling into part five, tracing the code, or as I like to call it, playing the detective.
Let's look at a live scenario. Imagine you have a file named attendance.txt, and it already has two names sitting on separate lines, Lena and then Omar. So what happens if we run a script that opens this file in append mode
and writes the name Priya with a new line character. Take a second. Predict the exact final output in your head.
Okay, let's break down the investigation step by step. Step 1, we open the file in append mode. Instantly, our invisible file pointer jumps straight to the very end, right past Omar's name. Step 2, we assign our variable to Priya. Now notice, there's no file change happening yet. This is just hanging out in temporary memory. Step 3 is where the magic happens. We execute the write command and Priya is officially stamped into the permanent text file. Finally, step 4, we close the file, locking the data safely away. The final tally? Lena, Omar, and Priya.
The really interesting thing to notice here is the dual focus. If you want to be strong at tracing code, you can't just stare at the syntax. You have to track the invisible memory variables shifting around in the background, right alongside the visible, permanent changes happening in the text file. You're essentially tracking two different worlds at the exact same time.
Which brings us to our final section, Part 6, Avoiding Common File Errors, otherwise known as the cautionary tales.
Let's rapid fire through the traps that catch developers all the time. First up, simply forgetting to close the file. If you do that, your written data might never actually get finalized. Then there's the big one, accidental overwriting, the overwrite disaster. As we talked about earlier, if you open an existing file in write mode when you really meant to use append or read, you will silently and instantly nuke all the original contents.
Another massive logic trap is mixing up text and numbers. You have to remember, anytime you pull data from a text file, it comes into your program as text, literally just a string of characters. Even if the file contains the number 15, your program just sees the word 15. If you try to do math with that, like adding 5 to it, your program is going to crash or act totally unpredictable. You absolutely must convert it using a function like int before you try to do any arithmetic.
To wrap up this explainer, I want to leave you with a bit of a nightmare scenario. Imagine you're managing a massive, critical corporate server. You write a simple script to log a brand new user login. But whoops, you accidentally open the system's master log in write mode instead of append mode. What crucial history have you just permanently erased? The answer is every single log entry from the beginning of time. Gone in an absolute instant. File processing is an incredibly powerful tool that gives your code lasting impact, but it demands serious respect. So double-check your modes, track your data carefully, and please always remember to lock the vault when you're done.